Well, thank you again for your participation in this afternoon's program. I'm very delighted to have this opportunity to share with you our CyberGIS Center vision. So what is GIS? As background information, you've heard a lot about GIS today, and I want to alert you that we have multiple forms of S here, including systems, science, services, even society, synthesis of information and data. And the key point, of course, is geo and spatial or special requires special treatment. I want to point you to, as Ling was alluded to, the economic impact. This is a report produced for Google last year showing the economic value of geo services. This clearly is linking to the services meaning of GIS. This is between $150 to $270 billion global revenue, in contrast to computer gaming industry, which is $25 billion global revenue, and the global airline industry is about $600 billion global revenue. So this is a very massive space as to the economic and the societal impact, the kind of science technology we're referring to here. But backing off, we're really talking about a different age of science and technology, the age that we need to include computation and data on top of theory and experimentation. And Ling, from the keynote earlier, you already got exposure to the uniqueness of geospatial data representing literally any V you could come up with from the big data popular notion, variety, velocity, volume, veracity, value. However V you could name it, geospatial data is in that specific category. That means this is a very fascinating area for big data as to the challenges and opportunities we're talking about. And I'm not using the V's, I'm using concrete characteristics, I hope, to convey to you the nature of big geospatial data. And to reinforce what Ling mentioned, this is a picture of the 3DAP program on the USGS website, which clearly represents a killer problem for CyberGIS, yet to be defined. But holistically, we're talking about where we are in the major transition of science and engineering, and broadly speaking, all the research and the scholarship, even including humanities and social sciences. We need this spirit of the whole and is more than the sum of parts. After decades of sciences focusing on drilling down into stovepipes, now the need is increasing to have those stovepipes connected. And cyber infrastructure offers this pathway forward, and the big data is clearly the value proposition we need to resolve the related challenges to make this integration and synthesis vision work in the broad science and the research context. From NSF point of view, you might have heard of this SIF 21. This is a very bold action and plan behind multiple years of planning, just like USGS does its own planning and the National Science Foundation community does its own, this particular cases for cyber infrastructure. And I highlighted that red box on the right hand. You might read it, but this is to provide comprehensive, integrated, sustainable, and secure cyber infrastructure to tackle the most challenging science and engineering problems facing to the society and the science communities. But it's more than just infrastructure, right? We see the emergence of cyberspace. On the right hand, I was Googling yesterday to get some hooker into my talk. This is the Google Glasses joke. So we're living in both physical, geographical, and environmental space simultaneously. So be careful while you're running, but after you bump into that tree, you are still asking a GIS question there. I thought it's a good one. But the idea is how do we understand the interface and the interplay between cyberspace and the physical, geographical, environmental spaces is now increasingly important as we are creating this cyberspace as well as trying to solve most challenging scientific problems. And this particular attempt is to map, for instance, the virtual space of Twitter as it's reflected on geography, real world geography. And clearly it's a big data problem as you try to gather the tweets across the world. This is what we had from Twitter through some partnership with SGI, got access to the decahorse, which is 10% of raw tweets. And this is hundreds of millions of tweets, and we were trying to do this in a near real-time fashion for analytics. And being able to map out this kind of geographical representations, but it really is addressing the Twitter space. But in the cyberspace, there's clearly the perspective of resources and the services. As we know, we are going to this mainstream of parallel computing architecture. There are many cores, multi-cores, but also heterogeneous architecture, graphics processing units, as Lynn mentioned, and mobile devices, and millions of such devices across the world, and a lot of distributed information and data sources and providing services in clouds. And all of this I'm emphasizing, we're experiencing extreme scale computing information and communication systems. Before the term of CyberGIS was coined, this is not the world of GIS. GIS was created without any knowledge of this extreme scale computing information communication systems. So we have to rethink what GIS should be and ought to be in the context of this. So CyberGIS is riding on this wave to be a term to get us with a reasonable grip with what's going on here. As an example of cyber resources, Blue Waters here, run by this organization and is a cutting edge cyber resource, and you'll be thinking of this kind of resource with 1.5 petabyte memory down in, say, 8 to 10 years become your personal computer, right? Because my laptop was a supercomputer 10 years ago. So are you ready for your analytics, for your problem solving, to be residing in this environment? I think we have a whole lot of work to do to ready the basic tools and knowledge production processes in this kind of environment. And we have to do that work today, otherwise we would be falling behind for solving important scientific problems and contributing valuable research to the broad data science revolution. So why we established CyberGIS Center here at Illinois? Well, there's traditional digital excellence at Illinois that motivated us to push this even to the next level. Web browser was born in this organization, and Blue Waters was another example. Geographic information science geography program here. But if you look at across campus, computer science, Graduate School of Library and Information Science, Peter mentioned, electrical computer engineering, ILIAC, all of this. This is all at Illinois. So we have this excellence built into our DNA. So to put this into the context of CyberGIS in a nutshell, my simple argument is today and moving to future, we are not able to separate between cyber and GIS. If you do GIS, you do CyberGIS. Because of the cyberspace we're living in, because of the cyber resources services we use, because of the tools and technologies we build for GIS, basically are cyber. This leads us to think how to manage the complexity of cyber resources and services, understanding the nature of cyberspace, and focusing on accelerated knowledge production and enabling scientific discovery. That's what CyberGIS has aspiration for. But along those tiers are tremendous opportunities for innovation, technological innovations, to manage the complexity of cyber to contribute to new innovative capabilities centered on users and customized to applications. That's what CyberGIS is about. Broadly speaking, this is pushed by advanced digital technologies and pulled by numerous discovery and innovation opportunities across a number of geospatial domains. But you look at it in the middle, this sort of cloudy, fuzzy thing, we yet to figure out what exactly it is. That's what gives us the aspiration for establish this center to go after the opportunities and the challenges. And you could see this is a rather complex ecosystem of its own in terms of filling the niche between the bottom and the top. Another dimension of excellence we have here in Illinois, why we established the center, is across geospatial and environmental realms. And we have agriculture college, civil and environmental engineering, those examples, just as a few. Some gallery of concrete work across campus I want to just quickly share with you. This is an image from Don Kiefer in the audience working on high-resolution hydrogeological prediction. This would be a perfect example if you have high-resolution LiDAR data, for instance, would be better informed this kind of modeling. So you would add even more additional scientific insights and endeavors on top of the data-driven scientific approaches Lin was alluded to in his keynote. But this is not only just the physical sciences. This is an art production. My group is working with Donna Cox's group here, and she was collaborating with a group of artists to portray this great flood 1927 that happened along the Mississippi River. And this is leveraging the NED data set Lin was talking about. In fact, there was a collaboration. My group had Lin to figure out how to more efficiently access NED data sets and extract NED data sets just for the Mississippi River Valley to make this art project successful. And this is going around the world, viewed by hundreds of thousands of people in numerous performances. So this is arts and humanities, right? And that gives you the breadth, as Peter was talking about in his welcome remarks. So we have this broad spectrum of excellence and progress on campus, which would be very synergistic with what we hope to achieve in this center. And also big geographic data simulation. Budu was giving his distinguished speaker's talk this morning about how data-driven big computing would make difference in sciences. So this example is clearly the one that you need to leverage very detailed spatial data, high-resolution spatial data, population, movement, but on top of that, some scientific processes you have to couple. And this is millions of individuals moving around the landscape. You're both consuming a whole lot of observational data, but you're producing also equivalently large amount of data for you to interpret and to understand, in these cases, disease spread. So one new partnership we're fostering is with the Klein Center for Democracy here. These particular examples, they are curating this very unique data set about conflict across the globe, extracted from news sources and social media. Very classic, unstructured, noisy data-based geospatial knowledge production, but it customized into very different domain contexts. In this case, it's studying the social political struggles and also the consequences. And without the kind of understanding I was talking about, bridging the cyber and geospatial realms, we probably cannot go too far here. Another example related to complex spatial decision-making, this is a collaboration with Luis Rodriguez, agricultural and biological engineer here on campus, studies how to, in an optimal fashion, place biomass storage and refinery facilities given emerging bioenergy infrastructure. Again, the uniqueness of this study is we're not only just talking about run a model, we're talking about couple that model in a rich geospatial information context and make the model and information synthesized results to stakeholders in an interactive fashion for facilitating their decision making. More importantly, this is enabling them to ask what if questions and making them get access to complex cyber infrastructure without knowing actually that's the infrastructure behind the scene to make this all happen. So some examples at Illinois, but also I want to share with you this particular example as an evidence this is rather a community broad development in this context. This isn't a project I'm leading with 9 institutions involved, Ling's Center of Excellence for Geospatial Information Sciences also participating, about 30 folks. The NSF funding is modest size, but with the group like Budus and the Ling's Center participating without the support from NSF, we're actually amplifying the impact this project could achieve beyond the level of investment from NSF, and also industry participation from ESRI. So this is giving us the evidence that we see this is representing a very exciting science and technology area, broadly speaking. In that project, we're asking this question, although I told you a little bit what CyberGIS is, but the question of what CyberGIS is for and for whom, and this project's going after this basic question. The idea we had so far in the project is CyberGIS really cuts across a broad spectrum. On the right hand, you see the gateway, which is this millions of users of CyberGIS. What should CyberGIS be for millions of users? How do you lower the entry doors for CyberGIS analytics to be accessible to numerous scientists who are not technical GIS savvy, or even general public to benefit from the knowledge and information produced through CyberGIS? And on the other hand, CyberGIS Toolkit, the vertical axis there, this is the basic building blocks, is novel algorithms, scalable codes to have future or current generation of data computational scientists to vet, to understand what should be those basic building blocks is. So this is rather for a much smaller population if you consider the broad user base of CyberGIS, millions and millions of users. This is perhaps very small, just for the scientists working on data and the computation in the CyberGIS context. What's in between is this libraries, middleware services that allow for customized application development, bridging between the toolkit and the gateway. So what kind of communities are we talking about? CyberGIS is really a meta community, and it includes communities that are interested in geospatial as a means to integrate knowledge and looking for geospatial insights through data and computational mechanisms. So this is a map of worldwide current users of Gateway. You see is from all the continents have active human habitants. And we're trying to do in the CyberGIS Gateway to be able to interoperate with the mainstream industry solutions such as ArcGIS. So the right-hand picture shows you could access ArcGIS online data resources from the CyberGIS Gateway. This is actually a diagram prepared by ESRI colleagues. They are depicting the relationship between their ArcGIS online resources and tools and the CyberGIS Gateway. The potential connection there is API to interact with each other across this broad space. So this shows you CyberGIS is getting to the mainstream, not replacing what's happening in the industry, but rather complement and enhancing and provide valuable expansion we must have getting to the big data and computing world for new scientific research and also knowledge production. And the CyberGIS Toolkit, as you saw, one of the building blocks is P-raster, blaster That's a library contributed by Lin Center working on map reprojection, particularly focused on raster data. This is open source. You could get to download, and if you're comfortable with coding, you could even contribute your improvements back to this open source toolkit. As an example of this open source toolkit, we have a piece of library focusing on spatial optimization based on genetic evolutionary computation. This is actually running on Blue Waters. One scientific case driving the development of this library is political redistricting. As you know, that's a complex geographical problem and also well-studied problem in political science. As we go down to finer spatial units, you would get to this explosive size of search space. You don't want to do this on your personal computers. Neither do politicians want to know about this. But scientifically, this is very important, but also societal impact would be huge if we understand the ramifications at a very fine spatial scale. And this, even Blue Waters, I would say, is not adequate in terms of the computing power needed because this potentially could become a public tool for general user to evaluate or understand the ramifications of different redistricting scenarios. So coming back to this push from technology and the pull from discovery and innovation, I'm attempting to fill in with what I discussed from the community CyberGIS project, the toolkit pushing to the deep computational and data sciences universe, and the gateway pushing to the broad access, open access gateway framework and middlewares tying different pieces together. And this is all built on advanced cyber infrastructure resources and services. And this is all driven by integrated digital and spatial studies. Remember my argument, we have increasingly hard time to separate between cyber and spatial. And this leads to opportunities and challenges for performing integrated digital and spatial studies. And what this requires is a whole new fertile field of combining spatial and computational realms at scale. At scale means, say, think of the massive global multi-scale connections we're talking about, either simulating disease or understanding people's mobility. The world is very connected. How to model this world, right? Distribution, dependence, and all of these spatial concepts and characteristics. But computationally, at scale, when you have millions of cores, you map your spatial processes and models into these millions of cores. How could you grapple with this mapping at a scale? And this leads to fantastic opportunities of what I call spatial computational principles and theories, development of new things in this space. Requires workforce to be able to combine these two, but have tremendous potential to theorize new things and create new methods and associated tools. Why this is important? Just a very simple example I want to share with you. Yesterday afternoon, I was putting together the slides for today's talk. I was looking at CNN as a distraction because people are searching for the airplane in Malaysia, and you saw that map got me intrigued. This thing was on CNN for more than a couple of hours. So what CNN or somebody working for CNN did, using a web Mercator and draw a circle there, trying to show what is 2.97 million square miles. I'm very troubled by this. Web Mercator is not preserving area and distance, and you're drawing a circle on that to show what is the size of an area. And that circle would not be a circle on a real true globe representation. So people in that should have a little bit of critical spatial training to work with the digital tools. Otherwise, would be communicating raw knowledge. So this means we need to infuse our education and training into between basic and advanced levels to combining what I was talking about, the spatial aspects and the computational aspects in an organic fashion. And that's what the future workforce needs to pursue fantastic innovations and discoveries and creating new tools and technologies. And this is not something our university has done a great job for educating our workforce. We tend to create all kinds of departments and vote in single department and make things functional. That's a very niche. We think this center could be very valuable to foster open partnerships and open access approach to advanced education materials, being able to plug those materials into our curriculum evolution across the campus, but also rethink new curriculum and pedagogy, what's necessary for training the new generation that is able to cut across these two realms. Without either one, I would not think the movement into CyberGIS and the related science and discovery and research would be as fruitful as we would be able to bridge. So we have done a little bit to increase the awareness of science and technology frontiers in this space, including a special feature on PNNS and a recent one on International Journal of Geographical Information Science. And I'll highlight a few because these also were alluded to by Ling's keynote talk. We're clearly seeing a new world of science and engineering, broadly speaking, research and scholarship context, which we would have to think much harder as to what scalability means. Scalability means not only scalable to handle much larger data, but also scalable knowledge production and dissemination, and not create additional digital divide as we go forward. We have to be very mindful of that. As we see very capable infrastructure being created, what is the reproducibility of science, and who's owning the data and the infrastructure might actually lead to not reproducible science is another big question we have to ask. And interoperability, as we all want to be innovative and creative as many science communities, CyberGIS is evolving. How do we assure interoperability across data and tools and software, but also the many niches of geospatial knowledge infused into many domains? And how reliable is a piece of discovery might be, given that we're so dependent on so many cyber pieces we need to understand the complexity for. So coming back to this push and pull notion I was alluded to earlier, I see this facilitation by both very dramatic digital transformation as well as critical spatial thinking necessary for fostering this discovery and innovation and further advances of digital technologies. But in between, we see we could help fill the niche of these four areas that should be organically integrated to foster each other's advances. And I think this represents tremendous opportunities because of the uniqueness of geo and spatial. If we gain a firm ground for our understanding of these four areas, as to their interactions, we would be also able to contribute back to the broader cyber communities and other sciences and engineering and the research areas that are dependent on this kind of approach moving forward, their sciences and research. So for our center, as you know, for the entity we are putting together, people is perhaps the most critical element of the center. These are the different roles and perhaps the size also of the center. Right now we have about 30 faculty researcher affiliates. We expect this to grow to about 70 to 100 within the next 2 to 3 years. And we have a very active executive committee that provides guidance and advice to work with me and the center staff to be nimble and at the same time strategic to what we do in the center. And a collection of advanced infrastructure and the services. This is really, as I mentioned, a strength of Illinois here. And we have these three complementary pieces put together: Commons to foster community development and training, CyberGIS Desk to enable in-depth technical consulting and new initiatives development, and the CyberGIS infrastructure, including hardware and software. Of course, people are putting all this together. I'll leave you with a small set of grand challenges and opportunities for the center, but more broadly speaking, for the related communities. This is the thing that keeps me up during night for me to be fascinated about. The first one is to create a sustained, open, scalable, intelligent CyberGIS enabled by advanced cyber infrastructure. How do we do this? This is, of course, very 10,000 meter level kind of grand challenges and opportunities. And the center is not only focusing on innovative infrastructure, services, systems, but also advancing digital spatial studies, helping gain better understanding about locations, spatial relationships, and context dynamics in a complex and fast-changing world, and long-term transforming research and education in arts, humanities, engineering, and sciences. This is very resonating with what Peter said at the beginning, is our opportunities are vast as to the impact we could make. And also because of the complexity and the uniqueness of geospatial, if we could make advances here in this space, the applicability of our knowledge to other domains would be also tremendous value. And we've been fortunate to have received support from multiple agencies and the partnership with agencies and industry to give us an opportunity to plan this center. And this is all very much appreciated. And the units involved to also make this happen here at Illinois for the center to be established, their sponsorship is also greatly appreciated. And of course, people is another thing keep me thinking hard to have the talents we've already had. It's a privilege working with the folks here in the center, and we expect this picture will be very quickly updated with the new talents currently being recruited to join the excitement. With that, I'll take any questions, comments if I have time. Thank you for your attention. Yes.
Hi, Shaowen. Well, thank you very much for sharing your insights and lead us the future road to go. So I always have a really big questions in my head is when we move into the cyber infrastructure, my big concern is security. Mm-hmm. So is this cybersecurity is part of your consideration, or it's okay if it is not in the scope of this center, or is totally rely on the cybersecurity community people to do this? And I'm just wondering what's your thought about this. Thank you.
Thanks, Yufan, for that important question. In the cyberspace, cybersecurity will be a very important problem for time to come. And of course, in the thinking and making of CyberGIS as a subject of domain in research, it is also an important topic. For instance, in our NSF project, we partner with another NSF project researching CyberGIS security and also providing cybersecurity services to the communities headed by Wang Welch, used to be a staff member here, now is Indiana. So he's heading that team of understanding cybersecurity. Simple answer is yes, we have needs for cybersecurity, but also we need to understand what cybersecurity means in CyberGIS in our center effort for a lot of domains, as you could see the breadth of the domains I was alluded to. And depending upon the different domains, we might see different cybersecurity needs and solutions. This is another interesting thing related to CyberGIS and associated science domains is there's no single solution fits all situation here. Although we have the best, perhaps arguably the best cybersecurity experts in the building here in the broad context of NSF Advanced Cyber Infrastructure Centers or even beyond that, and we have interactions with those folks in our regular work. But I still see tremendous opportunities from the work going forward in the CyberGIS Center, posing unique requirements and the needs for cybersecurity solutions. Because some geospatial data, as this morning's talk by Budu, are very sensitive, right? And who owns the data, where to disseminate the data, and what is the outcome of data aggregation integration? What is the sensitivity of that? You could get a bunch of open data, but the outcome after integration could become very sensitive. So I could get whereabouts of all of the people associated, your address, your demographic information. I could derive something pretty interesting about you, and you don't want that information to be out there. So this is, of course, more than security. It's getting to the confidentiality, privacy issues. But even all together considered, I view the kind of domains we're in this geospatial context, providing both challenges and opportunities in the cybersecurity space. Broadly speaking, security in my world is inclusive of privacy and confidentiality, all of those issues. So James Cray used to be quoted for his statement, is not an exact statement I'm able to say here, but roughly speaking, he said he's working on astronomy data because it's free, so that he could come up with the most smartest solutions from the algorithms and system side. But if Jim's still around, I would encourage him to work on geospatial data because he would need a much higher level intelligence to make geospatial solutions work. Literally, the new future CyberGIS would be able to figure out all these complexities. In one example, you brought up cybersecurity, but broadly speaking, we have all the data pieces are valuable, and it's not free, but they have huge impact, both societal impact, economic impact, at least, as I mentioned earlier. I was warned I'm running out of time. If you have one more question, I probably could take it. Otherwise, I'm around here for the afternoon, and feel free to corner me. I'll be happy to chat with you. So you're thinking to corner me. So let's wrap up the session. Thank you very much. I hope you stay around.